Now let us solve some previous year's GATE problems. A thin plate of uniform thickness is subjected to pressure as shown in figure. So this is the XY plane, and uniform thickness plate is subjected to pressure, and forces are on XY plane, and there is no force along Z. Under the assumption of plane stress, which of the following is correct? If it is plane stress, then there should be no stress along Z direction. That is sigma Z must be 0. So normal stress is 0 in Z direction. This is absolutely correct. Normal stress is tensile in Z direction, not because normal stress is 0 along Z direction. Normal stress is compressive, that is also not correct. Normal stress varies in Z direction, also not correct. So option A is correct, and this is from GATE 2014. Now let us move to the next problem. The state of stress at a point is given by sigma x is minus 6 MPa, sigma y is 4 MPa, and tau xy is minus 8 MPa. The maximum tensile stress in MPa at the point, and this is from GATE 2014. We can calculate it easily by the expression of maximum tensile stress. But for your understanding, let me draw the Mohr circle diagram and the stress state of stress. That is, sigma x is minus 6 MPa, so this is compressive type. So this is 6 MPa. 6 MPa in compression. Sigma y is 4 MPa, this is positive 4 MPa. And tau xy is also negative, minus 8 MPa, that is along this direction, 8 MPa. So this is the state of stress. This is the state of stress. Now let me draw the Mohr circle. So this is tau axis, this is sigma n. So first of all, we will plot point A, that is minus 6 comma minus 8. Say this is minus 6 and this is minus 8. So A is minus 6 comma minus 8. Now let me plot point B, that is 4 comma 8. So 4, this is 4 comma 8. Coordinate of point B is 4 comma 8. So this is the Mohr circle. So this is the Mohr circle for the state of stress. Now what is maximum tensile stress? This is maximum tensile stress. This is the value of maximum tensile stress. What will be the value? Say this is O. What this is the center C. Now let us write down the formula. Sigma max is sigma xx plus sigma yy by 2 plus root over sigma xx minus sigma yy by 2 square plus tau xy whole square. So sigma xx is minus 6, sigma yy is 4 plus minus 6 minus 4 divided by 2 whole square plus minus 8 whole square. And from this we will get 8.43 MPa. So this is the answer to the problem. Maximum tensile stress is 8.43 MPa. So the answer is maximum tensile stress is 8.43 MPa. So this value is 8.43. Now let us move to the next problem. If principal stresses in a plane stress problem are sigma 1 is 100 MPa, sigma 2 is 40 MPa, the magnitude of maximum shear stress. What will be the magnitude of maximum shear stress? So let me draw the Mohr circle first. Sigma n axis, this is tau axis. Say this is the Mohr circle. And it is given that sigma 1, this is sigma 1 is 100 MPa. Because this is the principal stresses, sorry, 100 MPa. And this is sigma 2 is 40 MPa. This is not to the scale, this is 40 and this is 100. What it has been asked? Magnitude of maximum shear stress. Where shear stress is maximum? This is the point where shear stress is maximum. So this is the tau max, this is the tau max, this, which is, if this is center of the Mohr circle, that is nothing but, sorry, so then this is the radius of, nothing but the radius of the Mohr circle, because this point is, this is not exactly circle, this will be a vertical line. So this is the radius of the Mohr circle. Tau max is nothing but radius of the Mohr circle. So what is the radius of the Mohr circle? If this is 100, this is 40, then tau max will be, tau max, sorry, let me write down it here. Tau max is the radius. And what is radius? That is 100 minus 40 by 2. That is 100 minus 40 is 60 by 2, that is 30 MPa. So radius of the Mohr circle will be the maximum shear stress, and that will be 30 MPa, and this is from GATE 2009. This is tau max. Tau max is always radius of the Mohr circle. Now let us move to the next problem. The state of stress at a point given by sigma xx minus 200 MPa, sigma yy 100 MPa, and tau xy 100 MPa. The maximum shear stress. What is the maximum shear stress? First, let me draw the Mohr circle, that will give you a better idea. Sigma n, this is tau. Sigma xx is minus 200. Sorry, we have to go for negative axis. So let us plot tau here. And sigma xx is minus 200 and tau xy is 100. So minus 200 comma 100. So point A is minus 200 comma 100. Okay. And what is tau? Sigma yy is 100. So point B will be here. Here. So B is 100 comma minus 100. Now join AB and at center here C, draw the Mohr circle. So this is the Mohr circle. And what is the maximum shear stress? Maximum shear stress is nothing but the radius of the Mohr circle. This is the maximum shear stress. So this is tau max. That is the radius of the Mohr circle. And what is the equation? Tau max. Now right now I am putting the equation, that is root over sigma xx minus sigma yy by 2 square whole square plus tau xy whole square. Put the values. Sigma xx is minus 200, yy is 100, and tau xy 100. So putting the values, tau max is root over minus 200 minus 100 divided by 2 whole square plus 100 square. That is root over minus 150 square plus 100 square. So tau max becomes, from this you will get 180.27 MPa. So this is the answer to the problem, 180.27. So this matches with our answer. So option C is correct here, and this is from GATE 2010. Now let us move to the next problem. A shaft subjected to torsion experiences a pure shear stress tau on the surface. Pure shear stress, sigma xx is 0, sigma yy is also 0, and tau xy is tau. So this is the state of stress in pure shear. This is the state of stress in pure shear. The maximum principal stress on the surface, which is 45 degree to the axis, will have a value. So now first let us draw the Mohr circle for pure shear. So for pure shear, this is sigma n, this is tau axis. Where will be point A? Point A is 0 comma tau. So here, say this is the value A. The coordinate is 0 comma tau because sigma xx is 0. Where will be point B? Point B will be 0 comma minus tau. So somewhere here B is 0 comma minus tau. Now we should draw Mohr circle by taking AB as diameter or OA as radius. So this is the Mohr circle. So this is the Mohr circle. Sorry, I am extremely sorry. So this is the Mohr circle. Now where phi is 0? Phi is 0 along this line. This is phi is 0 line. This line is represents phi equal to 0 degree. Now at axis which is on a the maximum principal stress on the surface which is at 45 degree to the axis. That is, if we take 45 degree in clockwise direction, then from these two we have to go 90 degree because in Mohr circle the angles becomes doubled. So if we take 90 degree, then we got this plane. On this plane principal stresses occur, and the value of principal stress is what? The maximum principal stress here, that will be tau, because radius of the circle is tau. So which option is correct? Tau cos, because principal stress sigma max, maximum principal stress is tau. So option A is not correct. This is 2 tau cos 45 degree, not correct. This is also not. But option D, that is 2 tau sine 45 degree is 1 by root 2 and cos 45 degree 1 by root 2, that is tau. So this option is the correct one. And this is from GATE 2003. So this is the Mohr circle for pure shear. And this is the state of stress for pure shear, where normal stresses are 0 and only shear stress is existing. Now let us move to the next problem. The state of stress at a point P in two-dimensional loading is such that Mohr circle is a point located at 170 MPa on the positive normal stress axis. Very interesting. Say sigma n tau, and Mohr circle is a point on 175 Mohr circle is a point located at 175 MPa on the positive normal stress axis. This is the positive normal stress axis, so this is 175 MPa. Determine the maximum and minimum principal stresses respectively from the Mohr circle. So if this is a point, then both max and minimum are 175. So max is also 175 MPa and sigma mean is also 175 MPa. Both are 175 MPa. So which option is correct? Option A shows both are plus 175. So this is correct one. Maximum and minimum both are 175 because Mohr circle is a point. Now the second one. Determine the directions of maximum and minimum principal stresses at the point P. Because here Mohr circle is a point, so all direction stress values are same. That is, all directions are principal planes. So all directions stress values are same, so all directions are principal plane. So this is from GATE 2003. At which situation, what is the stress situation here? The stress situation is along x direction, this is 175 MPa. This is also 175 MPa. This is 175. So both sigma xx and tau is 0. So sigma xx equal to sigma yy equal to 175 MPa and tau xy is 0. Then this stress situation occurs. So all directions are principal stresses. Principal stresses occurs in all direction. Now let us move to the next problem. The state of stress at a point on an element is shown in the figure A. This is the figure, state of stress. Here say this is x-axis and say this is y-axis. Then what is sigma xx? Sigma xx is plus p and sigma yy is minus p because this is compressive and there is shear stress is 0. The same state of stress is shown in another coordinate system. So this is another coordinate system and here this is this is on phi equal to 0 and state of stress at a plane which is rotated by 45 degree is same with the second coordinate system. So first of all, let me draw the Mohr circle for this state of stress. Say this is sigma n, this is tau. Sigma xx is plus p, tau xy 0. So this is point A. Sigma yy is minus p and tau is 0. So this is B. Now this is the Mohr circle. This is the Mohr circle and radius of the Mohr circle is nothing but P. Now where phi is 0, on this plane phi is 0, on this plane phi is 0 degree. Now if we rotate this plane by 45 degree, actually by 45 degree, then in Mohr circle it will be rotated by 90 degrees. So if we rotate it by 90 degree, it will come here. It is rotated by clockwise direction. So the plane in Mohr circle, we get this plane, that red plane, and the state of stress on this plane is what? That is sigma xx. Sigma xx is 0, sigma yy is also 0, and tau xy is p. Tau xy is p or minus p. You can say minus p. If it is rotated by clockwise direction, then it is minus p. If we rotate it by counterclockwise direction, they will get positive. So p or minus p. Now here the sigma xx is represented by tau xx. So tau xx will be 0, tau yy, that is sigma yy, is 0, and tau xy is p. So the components tau xx is 0, tau yy is 0, 0, and p. So which option is correct? This is not correct. This is also not. This is also not. So sorry, I am extremely sorry. Option B is correct because 0, 0, p. So we have determined 0, 0, and p. And this is also incorrect. So this is the answer to the problem, and this is from GATE 2016. Thank you.